Hey guys, welcome to another episode. I'm Hamam and this is the School of Cloud podcast. This episode is going to be all about Google Kubernetes Engine. I'm really excited about this topic. I'm doing something a bit differently this week. I've got a video version of this podcast. We're going to be doing a little bit of hands-on coding. So if you want to see sort of what I'm doing on my screen as I'm talking, then feel free to click on the YouTube link. I'm going to add it in the episode description. Alternatively, if you prefer to just listen, I'll be as descriptive as possible, and I don't think you'll miss too much. But I think I'll do a little bit more video versions or alternatives of the podcast episodes in future as well, because some people have asked me about it, and they said it might be a little bit helpful. So this episode's all about Kubernetes. I'm going to be walking you through a simple hello world Kubernetes cluster on your local machine to start off with, and then we're going to do something similar in GKE. When we're working on our local machine, I'll go through some of the Kubernetes fundamental as well as a little bit of a refresher. So just as a quick primer, if you've never come across Kubernetes before or you don't know too much about it, it's just a tool that's used for managing and running a lot of different containers, usually in the cloud these days. And installing Kubernetes is really, really easy, particularly on platforms like Mac and Windows. So I'm using a Mac machine at the moment, and if I want to install Kubernetes, I just open up my Docker desktop application, go to Preferences, and once I'm in there, there's a bunch of tabs that says General, Resource, Docker Engine, blah, blah, blah. At the bottom is Kubernetes. If you click on that, there is literally a checkbox there that is suitably named Enable Kubernetes. And it says underneath it, start a Kubernetes single node cluster when starting Docker desktop. If you check that, then you're good to go pretty much. There is one more thing you have to install. I'll go through that in a minute, but I'm not going to do that. My MacBook is pretty old, and the last time I ran Kubernetes locally on my laptop, it ran very, very slow. So I prefer to use a virtual machine when I'm running Kubernetes. I find it really easy to just install what I need, and then when I'm done, I'll just delete it. So I'm going to press cancel and get out of Docker desktop. But if you've got a fairly newish laptop, then that's the easiest way to get up and running. Alternatively, if you want to follow along with me, if you've listened to some of my previous AWS episodes, particularly the EC2 instance episode, you'll know that you can get a month's free T2 micro or T3 micro instances on AWS. So that's a great way to go if you want to spin up one of these instances and then follow along with the steps that I'm about to go through. Google Cloud also have something similar. They call it an F1 micro instance, and again, they give you a whole month's free in particular regions, I believe. So you have to go with US Central 1 or US East 1 or US West 1. And then DigitalOcean also have $100 free for 60 days if you sign up. If you just type into Google DigitalOcean free credit or free trial, that's what popped up for me, and the URL is try.digitalocean.com/free trial offer. And then their pricing is very simple. If you've used DigitalOcean, it's really easy to set up a droplet. You can pick which flavor of Linux you want, and the pricing is, as I said, the most simple, I suppose, droplet or virtual machine with one CPU and 1 gig of RAM will cost you around $5 a month. But since you only have 60 days to use the credit, so 2 months, you could go with something a bit more, unless you want to use it for something else, that is. But if you're just using it for Kubernetes, you can go with something a bit more powerful, and you'll find some of the steps that I run through will probably be a little bit easier as well. So yeah, as I said, the second point, before I go into installing it on Ubuntu on my virtual machine, the second point to talk about is, so you need Kubernetes, and you also need a tool called kubectl. So we're using a repo, like a companion repo, in this podcast. I've saved it under School of Cloud /GKE podcast resources, and I'll put a link in the episode description. But in the README for this repo, you'll find the steps that you need to install the kubectl command line tool. And this is just a tool that will let you interact with the main Kubernetes API and run commands against, the Kubernetes clusters. And there's a few options to do that. You can use, if you're using Linux, for instance, you can use the package manager on Ubuntu, the apt apt.get, using the apt.get command, and I believe on Mac OS you can use Homebrew or something like that to install kubectl. So there's a lot of different ways to install it. I've put the 4 basic commands that I got from the Kubernetes documentation, which is just doing a curl command, so grabbing the latest release of the CLI tool, and then running chmod +x on the kubectl binary to make it executable. Thirdly, moving it into your path, so doing sudo mv and then moving the binary. And on my Mac, it's I move it to user/local/bin/kubectl. And yeah, that's it. And then finally, you can run kubectl --help, and you should get. Let me try that actually on my Mac. So if I open up a new tab and I run kubectl --help, you'll get like a typical CLI tool help menu with all the different commands that you could use for this tool. So let's close that. As I said, I'm going to be using a virtual machine that I've just spun up. If I I do need to install Docker on this as well, because Kubernetes needs Docker as well when we're building images and stuff like that. So if I run docker -version, I don't even know if this is a Docker command, but anyway, it's telling me command docker not found. And if I try and run kubectl -help, again I get command kubectl not found. So the terminal is helping me out and telling me use run sudo snap install kubectl or run sudo snap install docker. So you can just follow the prompts that you're given. I do have a script that I could run that I've put into the companion repository. So let's clone that. And so I'm going to do git clone, pass in the URL, which is School of Cloud /GKE podcast resources. And if I do an ls on this, I need to go into it, and let's navigate into the repository. And then if we do ls inside here, you'll see there's 3 directories. There's a bin directory which has 2 executable scripts for installing Docker and Kubernetes, and this is the script has the steps, or the commands to install this stuff on Ubuntu 20. So if you're using something a bit different, you might need to use a different commands, or look for a different script. Excuse me. There's a demo repository and inside there we have the source code for a basic Go application. It's just a Go server that spits out hello world or hello demo, I think. And there's an info directory which has got some YAML files that we're going to go through to build out the Kubernetes sort of pods and services and things like that. So I'll navigate into the bin directory, and I'm going to pause this recording as I install Docker and kubectl. Hey guys, so we're back, and I've installed my Docker and kubectl CLI tool, and I did get one error when I was installing it, a permissions error. So I'll just I'll show you what I got in case you get the same thing. So I got this. I got permission when I tried after I've installed Docker. I tried to do Docker PS. Got this thing back that said got permission denied while trying to connect to Docker daemon socket, and there's a good explanation here of how to resolve it. I did have this in my script, so maybe it didn't run, but then when I just repeated these steps, it fixed the issue. So let's just get back into the repository. If I do Docker PS, for example, it says I've got no containers running. I'll just make that a bit smaller so you can see that. And if we do kubectl git pods, it says no resources found in default namespace. Perfect. So that's me all set up. So yeah, inside the companion repo for this podcast, as I said, you'll see, let's go to that. You'll see a simple hello world Go server. So that's inside the demo. There's a Docker file in there to create a Docker image out of this server. But if we go into main.go, it doesn't really matter if you haven't worked with Go. The code itself is really, really simple and really readable. We're just creating basically, it says here, creating something called a MUX router, which is quite popular in the Go world. And then there's this port here, 8080. And then at the bottom, we're doing a listen and serve. So kind of similar to most other programming languages, to be honest. And it's just a couple of lines. And this basically, there's a handler here. And it prints out, hello demo. So yeah, it doesn't. The focus of this episode isn't really the programming language or the Go. It's the Go code. It's just building the container out of this, and then writing or using the appropriate YAML file, understanding what that YAML code does to get Kubernetes to manage our container. So yeah, Kubernetes config files are written in the YAML syntax. This is really common. Most sort of configuration tools or technologies use YAML these days. And the cool thing about YAML is, I find at least, it's a great source of documentation. It's really easy to go in and scan YAML code. So let's just open up, for instance, the pod code, the pod example.yaml. And yeah, we haven't even gone into this yet, but you can sort of maybe easily scan this and see this is creating a kind.pod and it's referencing some sort of image. So it's quite easy to scan these YAML files and get more information about your Kubernetes cluster. And adding them into your source code also means it's easy to go back and see who made what change when. And this becomes incredibly useful when we're trying to debug problems in production. So initially we just want to create sort of a copy of our demo application and run it in a Kubernetes cluster. And then we want to try and get that application to be accessible from our network. So the easiest way to do this is to use the kubectl tool. And behind the scenes, this command is just going to send some instructions, the stuff that we're writing in YAML, to the Kubernetes API. And yeah, it's the Kubernetes API will pick that up and create what we want. In production, people don't tend to sit there and use, a CLI tool, just as with, I suppose with most other things. There are sort of ways to create pipelines that would read our YAML files and then tell Kubernetes to build, whatever it is that we want to build. But the CLI tool is really useful. And even when you're working in production, it's really useful to go in and grab information and to debug things, or just check what's going on in your cluster. So before we tell Kubernetes to create a pod with our container in it, we need to build a Docker image of the source code itself. So if you're following along and you've cloned the companion repo, let's navigate into the demo directory. So cd demo, and then we are going to tell Docker to use the Docker image inside this directory. So we've got the main.go file and we've got the Docker file. And if we just cat this Docker file, you can see it's saying from the Golang image, and this is sort of like a two-step process because the Golang image is really, really big and we want to build a really small Go container at the end. So initially we use the Golang image and we call it builder. And we're just saying this is our work directory, copy everything into this directory and then build the main.go file. And then the second step, which is basically we're trying to build a production Docker image using the Alpine image as base. The Alpine image is really small. I think it's like 4 or 5 megabytes. And I can't remember how big the Golang image was, but it's definitely a couple of 100 megabytes, maybe like 300 if I remember correctly. So in the second stage, we're just using the Alpine image and we're grabbing the main executable, and then we're exposing port 8080. So if you look at the source code, actually let's open that up in main.go. If you look at the source code, you'll see here it's listening on port 8080. So that's why we're exposing that port. So yeah, we want to build a Docker image, and when we're building the Docker image, we need to give it a tag. So the convention is to use your Docker Hub username. So in my case, I'm going to say Docker build -t for tag, and I'll say school of cloud dash, and then here we give it the application name. So let's just call it demo, and then finally we give it a version. So I'm going to say this is 0.0.1. And then don't forget the dot at the end, which just tells Docker, use the Docker file in this directory to build the Docker image. So whilst that's running, let's talk about pods. So later on, once this is built, we're going to give Kubernetes some instructions via the kubectl command line tool, and it's going to look for the Docker image and then run a container of that. You create a container from that image in something called a pod. So people sometimes use pods and containers interchangeably, but they're definitely not the same thing. Kubernetes doesn't run containers directly. Instead, it wraps one or more containers into a higher level construct called a pod. And generally speaking, all containers in the pod, in the same pod that is, will share the same resources, things like storage and local network. And this is really useful because containers can easily communicate with each other as if they were on the same machine. but they still maintain some degree of isolation from each other. And although pods can hold multiple containers, it's best practice to keep them as small as possible. So they should typically be holding only one main process. Although sometimes it's okay to have some tightly coupled helper containers, which are usually called sidecars, that are just helping what's going on in that main container. But if our application receives a lot of requests, keeping one container per pod makes it really easy to configure Kubernetes to create new replicas of that pod, and reduce the load on the first pod. And Google Kubernetes Engine and other cloud managed Kubernetes clusters are really good at that sort of thing. Load balancing and creating sort of failover strategies to help you in case something goes wrong. But we'll talk a little bit more about this later. So how can we get Kubernetes to run our demo container inside of a pod? The easiest way to do this is to use the pod example YAML, which is like a hello world example of how to create a pod, and that can be found in the infra directory. So if we go up one level, and let's go into infra, and I think there's another folder called K8 inside there. And if we list what's inside here, we've got a pod example YAML, a deployment example YAML, and a service example YAML. And we'll talk more about the deployments and the services in a few moments, but let's first look at what the pod example YAML is. So this is saying, in this config, we're basically saying, hey Kubernetes, can you please create an object of type pod, and that's it says kind pod. So look, can you create a object of type pod that has one container called demo, and this is the image for it. So School of Cloud /demo with the version number, which can be grabbed off Docker Hub. And I've put this on Docker Hub, so feel free to use that image if you don't want to push your own image to Docker Hub. So the spec is in this config. The spec bit is where we specify all the configuration about the image that we want to use, and the metadata part is where we give the cluster some additional information about the pod. It's a bit like using tags in AWS, for example, if you come from AWS world. And one other thing to bear in mind, if you haven't used much YAML before, there is a dash under containers, and that means it's an array that we're passing in. So again, you can specify more than one container in the pod if you like, and that's where you put it. So this is the basic, literally the most basic pod that we can create. So if we get out of this, to then pass that configuration file to Kubernetes, we say kubectl apply. And the apply verb is something that you'll probably see quite a lot in this tutorial. Every time we want to tell Kubernetes about some sort of configuration, then we'll use kubectl apply. And we use the -f flag to indicate that it should expect a file, and then we just need to pass the path to this file. And because we're in the directory itself, we'll just say pod example. And then it tells us pod demo created. So brilliant. If we now run kubectl get pods, we can see that it's telling us, or it's giving us a list of pods and their status, and we've only got one. So it's saying demo 1 out of 1, and status is running, and the age is 11 seconds ago. So that's fantastic. But when we manage pods in production, we don't typically do things like this. We create something called a deployment. And as I said, Pods are like the basic unit of computation in Kubernetes, but they're not directly launched into a cluster. Instead, pods are usually managed by a deployment, which sort of acts as a layer of abstraction. So in our case, if we want to create, for instance, 2 pods of our demo app, and then those 2 pods crash, the deployment is going to make sure that they're recreated, which is really cool. The deployment is also really useful for handling things like updates to the application. If, for instance, we create a version 2 of our demo app, the deployment will create 2 new version 2 pods, point traffic towards them, and then remove the pods for the first version. So then to look at the deployment file, again, let's open that up. And let's look at what this is saying. So this might be a little bit confusing at first because it looks like, or seems like there's a little bit of repetition here and there. But we start off with API version, and this is something you'll see in all Kubernetes configurations or manifests, YAML manifests sort of thing. Then we're saying the kind that we want is deployment. Last time we said pod, so we're telling Kubernetes what this sort of manifest is. But then what does the selector, label, and match label do? So the first metadata describes the deployment itself. It gives a label for the actual deployment. And the second metadata on the template is actually a pod template. So that describes the pod that's going to be launched. One of the fields for the pod templates is replicas. So when we set replicas to 2, we're telling Kubernetes, make 2 pods for this deployment, and the deployment would entail both those pods. So yeah, that template is for the pod itself. The selector match labels tells the deployment to match the pod according to that label. So it's saying create 2 replicas of the pod that has the label app demo. So hope that makes sense. It'll probably make a little bit more, if you're listening on the podcast, it'll make a little bit more sense if you just maybe on your phone have a look at the configuration. And the last spec section is very similar to the YAML we saw before for our pod. We're just saying grab the School of Cloud /demo image, and then from Docker Hub. And if we want to apply this change to our Kubernetes cluster, the one that's running on our local machine, we do exactly the same. We use exactly the same command that we used before. So we say kubectl apply -f, but this time we want to pass in the deployments example file. So now it says deployment, demo deployment created. And if we want to see that deployment, we say kubectl get deployment in plural. And it tells us there's 1 demo deployment, and we have, it says 2 out of 2, which means there's 2 pods created, and both of them are up to date. And if we want to do kubectl get pods, we should see now 3 pods running. So the first one was the pod that we created ourselves, and you can see from the age it says 4 minutes 45 seconds, and the second 2 pods were created by the deployment itself. So yeah, if you try to delete one of these deployments, so let's go ahead and do that. So we'll copy the ID or the name for one of the deployments that was created by, so one of the pods that was created by the deployment. So if we say kubectl, I think it's delete pod, the command, and pass in the name, it does say pod, whatever, it's a long name and ID, blah blah blah, deleted. But then if we say kubectl get pods, we should see that there is a new pod created. And you can tell, you probably won't see this, you won't realize this on the audio podcast, but if you're looking on the video, you can see the two IDs now for the pods are different to the ones before. So it's very fast, and the time also tells you, if you look at the age of the pods, you'll see that one pod is 90 seconds, which was when we first created the pod through the deployment, but underneath there's a new pod that says 11 seconds, the age. So even though we deleted one manually, one pod, the deployment created a second pod for us. So this shows the power of deployments. If you have some issues with your deployment, you can run the command kubectl describe deployment and pass in the deployment name, and I'll give you some debug information on it. So if you're following along, you might want to use that. And to delete a deployment, you can run kubectl delete deployment and pass in the deployment name again. So it's really, really simple. The kubectl tool is really powerful, and it makes life really, really easy. And the last command to know about is if you made a change to your Docker image. For example, say we changed the tag or the version on there, and you want your deployment to grab the latest version, then you would use the command kubectl rollout restart deployment and pass the deployment name. Obviously, you'd have to change the config file and add in the latest version, so it understands that it needs to grab that latest version from Docker Hub. But yeah, a nice thing about using these YAML config files is if you apply the same file, so if you do kubectl apply -f to the Kubernetes API, it won't recreate the deployments. So it's only going to make a change to your cluster if you've changed the YAML file itself, so the configuration inside it. And Kubernetes will understand that something has changed, and it will implement the necessary changes to bring the current state of the cluster in line with the desired state that you want. So this type of declarative configuration is one of the reasons why Kubernetes has become so popular. So let's now talk about services. It's the third really important concept that we need to understand. So we have a pod with our containerized application running in it. How can we actually make requests to that pod? This is where services come in. So a service lets us access the pod in our Kubernetes cluster, and also lets different pods communicate with each other. There are various different types of services, but the main, I suppose, three that we need to know about are cluster IP, which is the default service, and this allows the pods in our cluster to talk to each other. So if we have some event-driven architecture where one microservice publishes an event, for instance, to Cloud PubSub, and then other services are consuming that event, they would be using this type of service. Or another example is if one pod has your application in it and another pod has a SQL database in it, and the application needs to make requests to the database, again, they would use a cluster IP. And that's the default service. So if you don't specify the service type in the configuration, the YAML file, then it will assume that you meant cluster IP. The second really important, or I suppose quite common service is the node port. And this is used when we want to make a request from the internet to a pod in our cluster. So we use this service to make a HTTP request from our browser, for example, to the demo application running inside of the pod. And the third service is called the load balancer. This is really similar to the node port, but the node port is usually used in testing and development when we're trying to make a very quick request to one of our pods, whereas a load balancer is sort of the preferred option, particularly in a cloud environment. when using Kubernetes in production. So let's create a simple service for our cluster. I'm going to focus on using a node port because, as I said, if we're trying to test out something in development, it's probably the simpler way to go. And load balancer might be a little bit overkill for this simple example. So we've got this service YAML file. Let's have a look at that. So what was it called? Service example. So let's open that up in a text editor. And let's look at what this is saying. So again, we've got the API version similar to before. This time around, we're saying this is it's a type of service. And we have a selector in this file, which is telling the service what pods should be exposed. So we did something similar with the deployment, where we had a template section that described which pods should be created by the deployment. Here we're telling the service, find all the pods that have a label of app demo, and expose traffic to them from the outside world. In the ports section, we're telling the service which ports should be exposed on the target pod. So you might be asking yourself, why is the port listed twice, and what's the difference between port and target port? And the target port is the sort of the ultimate port on the pod that we want to expose. And we put down a value of 8080 because, if you remember, the application is listening on port 8080. The second port, which is just called port in the YAML file, refers to the port of the node port service itself. So these two port numbers obviously don't have to be the same, but I just found it a little bit easier to make them the same. But yeah, the worker nodes in the Kubernetes cluster also have their own port. So I may not have explained at the beginning, but in a Kubernetes cluster, we have the master controller, which is where the API sits, and we have worker nodes. And inside the worker nodes, we have these pods. So in our case, we're only working with one node on our local machine. But in production, you can have hundreds and thousands of nodes, and each node could have, any number of pods on it as well. So the node has its own port, the pod has its own port, and then the container has its own port as well. The service has its own port, and then the pod has its own port as well. And obviously the container does have its own port. I hope this is not confusing you, but basically what I'm trying to say is you can think of it a little bit like an onion with different layers, and you're trying to get to the center of the onion. And you can think of the center as your container, and each layer has its own port, and the traffic would just basically be navigate itself through those ports that are exposed at the different layers until it finally gets to the container itself. We don't have to worry about the node port. The only thing we need to worry about is the port for the service itself, and the port for the pod. So that's the only two things. And usually, as I said, just to make things easy, I usually make them the same as the container port that I've exposed. So to create this service, again, we're going to use exactly the same command. It is kubectl apply -f and pass it the path to the file service example.yaml, and that comes back immediately saying service demo service, which is what we called it in the metadata section. So the demo service has been created, and if we run kubectl get services, we should see that there are two services. One is for the Kubernetes API itself, so ignore the first one, And the second one says name demo service, type is node port, and it's given us a external IP address as well. So you'll see the node port service has been created. If you look on the right hand side, there should be a column called ports, and underneath that you'll see the port mapping that we just discussed. In my case, it's saying port 8080:32481. So that just means that the port for the worker node, so the outermost layer of the onion, is 32481. And that's been mapped to the port for the pod, which is 8080. So if we want to make a request to our application, we have to use the outermost port, because we need to make a request to the sort of the infrastructure on the outermost point, or the outermost layer of the onion. I'm getting a bit carried away with this onion metaphor, apologies. But yeah, Kubernetes will then just map that request right through to our application, all the way to the inner port that we've exposed. But basically, if we want to make a request to this, we just need to use that port. That's what I'm trying to say, which is in my case is 32481. You'll probably get something different. But if I do curl localhost colon 32481, I get hello demo, which is our server. So brilliant. So let's just recap what we've learned so far. So we said a simple Kubernetes cluster usually contains a master and one or more worker nodes. And in modern cloud environments, the worker nodes are usually things like virtual machines. So, on Google Cloud, that'll be Google Compute Engine, and on AWS, it'll be EC2 instances. And they're usually fully managed for us if we go with these sort of cloud environments. Obviously, we can spin up our own virtual machines and do everything ourselves, but we'd be paying the operational overhead for that. And these worker nodes come in different flavors of CPU and memory if you're in the cloud environment. So we'll go into more detail later on when we talk about Kubernetes Engine, but you can pick all sorts of memory and CPU that will address the need that you're looking for, or the performance that you need. We said the master contains the Kubernetes API and the control plane, and it's responsible for scheduling the worker nodes. So in other words, scheduling just means selecting which worker nodes should run, and also it controls the state of the overall cluster. Something I didn't discuss but might be of interest is the state of the cluster is saved actually on the master control plane in a key value store called etcd. So it's like a little database that the Kubernetes API uses. And again, all this stuff is sort of found on the master control plane. If we're using Google Kubernetes Engine, we don't even get to see what's inside the control plane. We don't manage that at all. It's all managed by Google engineers. So that's fantastic because we don't have to worry about it. And yeah, a worker node, we said, has a pod inside it which wraps one or more containers. Configuration details like the number of pods and the containers that they run are supplied to the Kubernetes cluster using something called the deployment. And finally, we said we use services to get pods to talk to each other and also to make HTTP requests to those pods from the internet. So for us to make those requests. So that was a wrap up of Kubernetes and everything that we discussed. It was a very brief introduction, but I hope that was useful. And I hope this is a good primer to now talk about Google Kubernetes Engine. So yeah, if you want to use, if you want to run Kubernetes in production, or you want to run a cluster yourself, you need to provision virtual machines for your master and worker nodes. You need to install Kubernetes and actually a bunch of other software that it requires on all of the machines. And you have to manage networking and security between all of the pods. And alternatively, you can just use Kubernetes Engine, which does all this for you, and it comes with a lot of other benefits as well. So it comes with things like, obviously you have a secure and fully managed Kubernetes service in the cloud. You have pods and cluster autoscaling. It's highly available. You can select to have it in a single zone, or you can have it in different zones and different regions. So it eliminates a lot of operational overhead, and it does things like auto repair, auto upgrade. It's secure by default. It does a vulnerability scanning on container images. The data inside the nodes are encrypted, and it has really excellent integration with cloud monitoring for things like monitoring the actual Kubernetes infrastructure, but also monitoring the applications inside, so what's going on inside the pod. So GKE gives us a lot of stuff that we don't have to worry about, as do obviously other cloud Kubernetes providers. But yeah, as I said, with GKE, we don't have any access to the master control plane, and that's a great thing, because Google engineers are managing that for us. They're the ones that developed Kubernetes, and they understand that very well. And that's a huge operational overhead that's removed, taken away from our shoulders. And we can, of course, interact with the master using tools like the Google Cloud Console and the Cloud Shell. So let's look at how we can deploy our demo application that we've been working with to Kubernetes Engine using the Cloud Console, so the UI. So sign into the UI if you haven't done so already, and then on the top right hand side, there should be a button that says Activate Cloud Shell. So let's open that up, because I think that's going to be quite useful for us to run a few commands. I'm going to show you how to do it with the UI console, and then we'll do everything with the Cloud Shell itself. So I'll show you both ways, but we'll start off with the UI. But I just want to set up the project, or show you how to set up the project using the Cloud Shell if you haven't done that already. So this should take a minute or two to provision. So let me just pause this while we wait. So we're back here. So we're in the Cloud Shell, and it's provisioned for us. So I think this runs in a container. So I'm just going to open it up in a new window, so we get the full screen view. And we can dismiss this message. And I'll just zoom in a little bit so you can see it better if you're following on YouTube. We can close this first one. So yeah, I've just opened up a Cloud Shell, put it in a full window. So the first thing we want to do is just activate the shell using our account name. So we'll run gcloud auth list. If I can type properly, so gcloud auth list, and that'll just give you a prompt to authorize the Cloud Shell. So click on the blue authorize button, and then you can see your projects by running gcloud config list projects or project. I'm having a bad day with this gcloud command. Okay, so that's telling me which project is active. So it's just for you to check which project is the current active project in gcloud. You might want to change it to something else. So yeah, once you've set up the basics, we need to activate the Kubernetes Engine API in Google Cloud. This can be done through this gcloud shell, or you can do it through the UI. If you navigate to the UI, it will by default enable it. So if you just go to Kubernetes Engine in the UI, it's just saying Kubernetes Engine API is being enabled. This may take a minute or more, but I'll also show you how to do it in the Cloud Shell while this is enabling. So in the Cloud Shell, if you want to see which services or which APIs, in Google, pretty much everything you use has an API, and you have to enable the API before you start working with it. If you come from an AWS world, then you don't have to do this. So it might seem a bit strange at first, but you sort of get used to it. And if you want to see which services have been, or which APIs have been enabled, you say gcloud services list, and then pass in the enabled flag. And this should be just a bunch of services that get enabled by default when you first start using an account. So I didn't enable any of these, but things like cloud monitoring, cloud logging, and some basic stuff. So this is enabled in the UI, but then, as I said, let's see how to do it in the Cloud Shell. If you want to see a list of the entire APIs that are available for you, or that you have permission to enable, you say gcloud services list again, but then this time you pass in the available. Have I spelled that right? Available flag. No, I didn't spell that right, did I? So gcloud services list available. That should take a moment, and yeah, that just brings me these are all the APIs that I can enable, and you can see there's loads of them. And the Kubernetes API is actually called container.googleapis.com. So to enable that, we just say gcloud. Let's clear this first. Gcloud services enable container.googleapis.com, and I think it should tell me it's already enabled. Well, it didn't say anything. Okay, if it wasn't enabled, you'll get some sort of confirmation that the API has been enabled. It just says operation, it gives you an ID, and then it says finished successfully. But I think because I enabled it through the UI, I've got nothing. So let's head back to the UI, because we're going to use that first to create the cluster. And there's a big blue button that's saying create cluster. So go ahead and click on that, and you'll be taken to the Kubernetes Engine wizard, which is going to help us create our first cluster. So for the cluster name, I'm just going to call it demo cluster. And you'll notice underneath it says location type, and there's two options, zonal or regional. For this cluster, I'm just going to stick to the default. So I'm going to keep it as zonal. So default US Central 1C, but feel free to use a region that's close to you. The default option is the zonal one. So cluster control plane and the nodes usually run in a single compute zone that you specify when you create the cluster. But the regional clusters sort of increases the availability of both the control plane and also the nodes, because it replicates them across multiple zones in that specific region. So if you select the regional option, Kubernetes Engine is giving you a highly available cluster that's going to help you with disaster recovery and things like that if there's an issue in one of your zones. So yeah, this option is really great in terms of like high availability. It also helps with things like cluster upgrades. If you're doing sort of cluster upgrades, you've always got one available cluster in one zone within the region. But it does come at an additional cost. And I think if you do click on it, I do recall that Kubernetes Engine at one point gave you, it's not giving it to me now, but it did give me, or maybe when you press create, I don't know, when you were trying to create it, it did give me a sort of a hint at one point to say, hey, this is going to cost you a little bit more. It also uses, if you're on a sort of a free tier, you've usually got a quota of how many nodes you can run in a region. So using the regional option will obviously use up a lot of your project's regional quota. So yeah, let's explore some of the other options. Below the cluster basics tab, on the left hand menu we've got something that says default pool. So if we click on that, that's giving us information about the node pools. So workers in Kubernetes Engine are called nodes, and when you create a node, it always belongs to a node group. There's a nice explanation at the top, which is telling us a node group is just a template for groups of similar type nodes created in this cluster. And if you come from an AWS world, you can think of this a little bit like a launch type for EC2 instances, or maybe another analogy that I can think of that's slightly similar is ECS task definitions that are used to launch Fargate tasks. For the time being, we're going to leave everything as default except for the number of nodes. Let's use 1 to make this a little bit cheaper. And then, and then for under default nodes, there's another tab that says nodes. If you click on that, that has specific configuration for the node itself. So for the node type, we're going to go with N1, the first generation, and then go with G1 small. And again, that's just like the cheapest version out there. So it's just because we're just learning, it's just going to save us some money. And then yeah, we can click on create. And that's going to take a few minutes to create. So I'll pause it here and I'll start it again once it's created. So my cluster's been created, and if we click on the demo cluster link, we can see all sorts of useful information on the cluster itself. And you'll notice at the top there's 3 tabs. The first one is details, with all the nice sort of information on the cluster. Then we have a storage tab. We don't have any storage at the moment, but if we did provision some storage, we'd find some information on it here. And we have our one node that we selected, and again there's all sorts of useful information on that. If we do click on the nodes link, we'll get a lot of nice monitoring data on the health of the node. So that's really, really useful. Now we want to deploy our Go demo application to this cluster. And the easiest way to do this is to push our Docker image to Google Container Registry, which is like Google's version of Docker Hub. And we can do this using the Cloud Shell. But first we have to clone our repository. So let's go back and grab the link And inside the Cloud Shell, we'll say git clone, pass in the URL. So that should be saved for you in the Cloud Shell. And then if we change directories and go into the GKE podcast resource directory, and then move into our demo directory where we have our Docker image, we just need to build the Docker image again. And again, the tag we give it is quite important. It needs to be gcr.io / your project ID. So whatever project you're using in Google Cloud, / the name of the application, and then colon the version. So not too different to before, but before we had Docker Hub. This time we're using gcr.io, which is Google container registry. So let's say docker build, and we'll say -t for tag gcr.io / and then to get my project ID, I can find it in the UI at the top, and I'll just copy and paste that into this tag /demo and colon. We'll use the same versioning that we used before, 0.0.1, and then don't forget the dot at the end. So that will build the Docker image again, just as before. And then once that's done, all we have to do is push it to Google Container Registry. So it's very, very similar. Instead of going to Docker Hub, it's going to Google's private registry. So our Docker image has been built successfully, and we've been notified that it's also been tagged with the tag that we wanted. So all we have to do now is say docker push, and we'll give it that whole entire tag for the image, and this should push it to Google Container Registry. So we will head over there in the console. You can just search it at the top, just say Google Container. Okay, that doesn't seem to bring anything. Maybe Container Registry. Yeah, there we go, Container Registry. And we can see our image pushed up there. And then if you click on the image, it'll take you to some details on the image itself. To deploy this image to GKR, there is a really nice deploy option here, like a drop down. And if you click on it, it says deploy to Cloud Run. And then it gives us options to deploy to GKE, Kubernetes Engine, and also GCE, Compute Engine. So we'll go ahead and select deploy to GKE. And we have a similar option in, there's a way to get to this through the Kubernetes Engine menu as well. It's just under the workloads tab. It's actually taken us straight there. But this time it's pre-populated the image path for us, and we can press continue. I think it'll give us here an option to select the application name. So it's just given us Nginx. I think that's the default name that is pre-populated for us, but we can put down demo for our application name just to keep it consistent. And I believe that's everything that we have to do. We can just say deploy, click on deploy, and that should deploy our image. So it's very, very easy. So Kubernetes Engine has deployed the image for us, the Docker image, and we've landed in this page for it's under the Workloads tab. And there's a lot of interesting stuff going on here. Firstly, you'll notice that GKE has created an active revision for us. So that's just here under active revisions. So that's awesome because it means Kubernetes Engine is managing different versions of our application. And this makes it a lot easier to do things like rollbacks and blue-green deployments and all that cool stuff. Secondly, you'll notice that even though we only created one node, to keep costs low, Kubernetes Engine has nicely created 3 pods for us in that node. So there's some replicas there for our application, and it's going to spread the load nicely for us. And after a while, if your application doesn't get any traffic, GKE is smart enough to actually reduce that to 1 pod. And then at the top of the page, we're getting a nice message here as well. There's something about set up automated pipelines for this workload. So it'll sort of take you through a wizard to set up an automated pipeline if you want. We don't want to do that right now, so we'll dismiss that. But the second message is quite interesting. The Kubernetes Engine is prompting us to create a service so that we can make HTTP requests to our application. So go ahead and click expose on that. So our application is listening on the target port 8080. So we just need to add that port in the target port area and or field, and then we can click on expose. And now Kubernetes Engine is going to create a load balancer for us. Remember, we said that this is the more appropriate service to create in production when compared to a node port. The load balancer is going to round robin all requests to all the pods in the cluster. And if you've never come across round robin load balancing before, it just means each time the load balancer DNS name is queried, it sends the IP address to which it most recently responded to the back of the queue. So the pod that most recently used for that IP address, it sends it to the back of the queue, and it operates in a loop. So the IP addresses in a round robin DNS process is a bit like baseball players in a batting lineup. Each one gets a turn to bat and then is moved to the back of the line. The request is then served to the latest pod that's picked up from the back of the line. It's very simple, but it's really effective process at sort of balancing out the load. And yeah, once the service is created, we're taken to the service and ingress tab now. So Kubernetes is sort of Kubernetes Engine is just automatically taking us to the right place. And in the GKE console, and here we can see if we look just a little bit further down the page, there's an external endpoint that's created for us. And if we click that, it tells us, it just basically tells us you're going to a external IP address. But if we click that again, we can see the hello demo response from our application. So yeah, that's the HTTP response from our Go server. So that's brilliant. It was really simple to create this with the UI, but I would like to recreate this with the Cloud Shell, and I'll show you how to do that with the Cloud Shell. So I'm just going to delete my cluster, and I will recreate it again. So if we go to clusters, we can just delete that. while that's deleting, we'll head over to close this page. We'll head over to the Cloud Shell. So let's repeat the same process. So creating a Kubernetes cluster, but this time around, I just want to show you quickly how to do the same thing in the G-Cloud, using the G-Cloud command line tool. So using this Cloud Shell. So the command to actually create the cluster looks quite long. I'll just paste it here into our Cloud Shell, and then we can go through it. But it's actually pretty much all the things that we selected in the UI. And there's a few things in here that are defaults that we didn't really explicitly select, but it chose Kubernetes Engine just sort of implicitly chose for us. So if we look in the UI, you can see that I've actually deleted the cluster that we just created, and we don't have anything here anymore. So in the Cloud Shell, the main command that we need to run when we're creating a cluster is gcloud beta container clusters create. So this is really the main thing here, and the rest is all options. And we pass in a name for the cluster, so we'll call it demo cluster again. Then underneath, pass it a project. Underneath that is the zone. So that was enabled for us, or it was sort of like pre-populated for us. We don't want any sort of authentication. This cluster version was on 1.16 for us. The machine type, if you remember, we chose as G1 small to keep costs low. And then some of the other important options here. This size we didn't really play around with. Scopes we didn't play around with. Number of nodes we changed to 1. So I'm selecting that here as well. This enable stack driver Kubernetes is just about logging, and yeah, the rest of the stuff was just default options. To sort of get this is actually quite easy. You can, and this is something that I really like about Kubernetes. If you're creating something in the UI, I'll just quickly show you here. Once you've selected some options, you can go down at the bottom and it says equivalent REST or command line. And this is something that I wish AWS and Azure would do, because I think it's absolutely brilliant and it sort of promotes automation. So if you click on that, the Kubernetes Engine from the UI will give you the equivalent G-Cloud command line tool that you could then put in like a bash script or something like that. So yeah, I just grabbed that from there. So if we run that, so when you run this command, it just spits out some warnings at the beginning, and then it tells you that it's creating the demo cluster in US Central 1. So yeah, we'll just pause this and we'll resume again once the cluster's been created. So once this is finished, this is telling us the demo cluster has been created in US Central 1C, and it's giving us some information on the machine type. And then if we go into the UI, go back into clusters, we should be able to see that as well. There we go. So exactly the same thing. And then before we can use kubectl in the Cloud Shell, the first thing we need to do is authenticate kubectl with our cluster, and this sort of points the kubectl command line tool to our cluster in Google Cloud. So then when we do something like kubectl get pods, it understands that it needs to grab the information from a remote cluster in Google Cloud, so from Kubernetes Engine. And the command is gcloud container clusters get credentials. So we need to run gcloud container clusters get credentials, and then we give it the name of our cluster, which is demo cluster, and we also have to pass in the zone, which in my case is US Central 1C. And that just tells us basically it's authenticated kubectl for our demo cluster. So now if we do kubectl git pods, we'll see there's no resources at the moment running in our pods, which is what we expected. So to deploy the demo app to the cluster, assuming that you still have the image that we built and pushed to Google Container Registry, we can just use the kubectl create deployments command in the Cloud Shell and pass in the image. So we'll say kubectl create deployment. Kubectl create deployment. Let's call it demo app, and then we pass the image flag, and we say the image in our case was gcr.io, and then I need to grab the project ID. So in my case, I can just grab it from the UI, paste it in there, and we called the image demo, and the version was 0.1. And again, I'm spelling kubectl wrong. Probably done this like 100 times. And then that says deployment demo app has been created. Brilliant. And then we can just double check that obviously by saying kubectl get deployments. And we have one deployment that's 13 seconds old. The next thing we want to do is, so we have the demo app running, and then when we created this in the UI, it helpfully told us, do you want to expose the right port? So we want to create a service that will export port 8080. And in our case, again, because it's production sort of cluster, usually you'd end up creating a load balancer. So the command here is kubectl expose deployment, and then we pass in some information to that. So we say kubectl expose deployment. We called it demo app, and we want to pass in the port that we want to expose, which is 8080, and also the type of service that we want to create, and in this case it's going to be load balancer. And that was very, very quick. Again, it's created the load balancer for us, and if we want to get information on that, we just have to say kubectl get services, and you can see there is a Kubernetes service already present. That was created for our cluster when we first created it, but on top of that we've got a load balancer service, and it's saying pending at the moment because it's still creating it, but eventually it's going to give us an external IP address that we can query. So let's just hit that again, and here we go. We've got it 34.122.192.73 in my case. So if I copy that, and I'll put that in a browser, and I also have to add the port 8080 to it, we should get the hello demo response from our Go application, which is now in obviously in a pod in Kubernetes Engine, and we've just created all of that from the Cloud Shell, which is really cool. We can do a few other useful things in our cluster using the kubectl tool. So for instance, say we want to increase the number of nodes that we have, we can say kubectl scale deployment, pass in the name of the deployment, and then say we want 3 replicas. So replicas equals 3, and that's gonna go ahead and create some deployments, some extra nodes for us. And alternatively, if we want to specify a horizontal pod autoscaler resource for our deployment based on something like CPU utilization, for instance, we can say something like kubectl auto scale deployment. Again, pass in demo app, and then say we want to base this on CPU percent equals 80, and we want to have a minimum of 1 pod and a maximum of 5. So now if we were to load test our cluster, this is going to also scale the pods for us automatically. One other useful thing that you might want to I guess try is, say you want to make a change in your source code. How would you then deploy a new version of your app? So again, this is really easy. If we the Cloud Shell does come with a code editor, so let's see where that is. I think I may have opened it and closed it actually. Let's open it in a new window. So this is quite useful just for editing code. So I can see the directory that I cloned, and then if I go into the demo directory and look at my main Go file, there is this line on line 17. It's there's just a variable called demo, and then it's writing hello demo to the basically just to the response that it sends to whatever queries the server. Say we want to say hello demo version 2. Let's save that, and then we need to go back to our Cloud Shell and rebuild the Docker image. So we want a new version of that, and we can call that version 2. So we'll say, oh dear, hang on a sec. So we'll say docker build, pass in the tag again, and we're saying gcr.io, and then I keep forgetting my project, so let me copy that again. I can actually query the project using this Cloud Shell, which might be a bit easier. So that's my project name, and then the app, again I'll call it demo, but this time around I'm going to give it a version of 0.0.2, and I want to build that. What is that saying? Unable to prepare context. Where am I? I'm not in my Docker file. I'm not in the right directory. So let's go into that GKE demo, and let's build that again. So that's just going to build for us, and once that's built, all we have to do is then push it to the container registry again, and then we should be able to go into the container registry and hopefully see a new version of our application. So let's say docker push, and we'll just copy and paste the tagged image, and that should have pushed it into container registry. So if we go there, let's search for that in the UI and look under demo. Yep, I see 2 images there, and there's the tags are very helpful. So it's telling me the top one is 0.0.2, and it's just been uploaded now. So that's really useful. Now we want to apply a rolling update to the existing deployment with the updated image. So let's go to the Cloud Shell, clear that, and then the command here is kubectl set image, and the deployment was deployment/demo app, and we want to say this time round demo equals the new where was it? Yeah, the new image that we just created. So what was that called? Let me just copy that. It's the same tag here. And then if I press OK, it says deployment image has been updated. So now let's go back to our tab. I've still got it open. If I refresh, let's see how quick this is. So I had to wait a few minutes, but I did realize, but it did eventually update it. I realized because I scaled up the cluster, it was just taking a long time to get the updated app up and running. So yeah, that's everything in terms of updating your application and then redeploying a new version of your application. If you want to delete your cluster, it's really easy. You just say kubectl delete service. The kubectl delete service would first delete the service. So you need to delete the service first and the deployment. And then finally, you would delete the demo cluster. So I'll show you the commands. So first we say kubectl delete service demo app, and I'm not going to actually delete it because I want to continue using it for one more thing, but I just want to show you this in case you're interested. And then you want to save some money maybe, so and then to delete the deployment, again, very simple, kubectl delete deployment and pass in the name demo app. And then finally, if you want to delete the service itself, you just say gcloud container clusters delete. So I don't know if you recall, but when we created the cluster, we said gcloud container clusters create. So this time we're deleting it. We just give it the name. So we called it demo cluster. And then you also have to pass in the zone again, just as we did when we created it. So you say US central 1C. So all these commands are available obviously in the Kubernetes documentation, the Kubernetes Engine documentation, on Google Cloud. And you can also delete the images as well in container registry. So the commands for that is gcloud container images delete, and then just pass in the tag for the image, the complete tag that we gave when we created the image. So in my case, it's gcr.io/project name /demo :0.01, and then the same thing for 0.02. If you want to see the logs for the pods that you've created, you can just do something like this. So you need to get the full name for the pod. So first kubectl get pods. So at the moment we've got one pod running. So I'm going to copy the whole name, and then to see the logs for it, I'll do kubectl logs, pass in the name, and you'll see that there's only 3 logs here. Starting server, which is just sort of it's just a log coming out of the Go server itself. And then there's these 2 requests that I sent in the browser for version 2 of the application that we just did. For our demo app, we don't have very sophisticated logging, as you can see in our server. So that's why you're just seeing these 3 logs. But yeah, these logs are also available in the UI console. So if you want to go to that, you should be able to see these same logs in the UI as well. So if you want to see that, you go into workloads and then click on the demo app, and then we have to go to, where is that, manage pods. So we click on the pods themselves, and then there is logs tab over here. Here, by the way, you can see some basic metrics for your pods, which is also useful. But if you want to go and see the container logs, you click on logs, and then there is a link there for container logs. And these are the same 3 logs that we just saw a moment ago in the Cloud Shell. And then you can open that up as well to get a bit more information on it. So it reminds me of a little bit like the Chrome console logs, if you've ever played around with those. So that's all that we have time for in this really basic introduction to Kubernetes Engine and creating a Kubernetes cluster locally on your machine. I hope you found that useful, and let me know how you feel about the video aspect of this podcast. And finally, don't forget to delete your cluster because obviously they will start charging you for it, particularly if you're running quite a lot of nodes and a lot of pods. Thank you for tuning in, and goodbye.